Today, we learn about reactions of benzene and its derivative. The main type reaction of benzene is electrophilic aromatic substitution reactions. In our syllabus, we have 4 reactions involving hydrogen atoms at benzene ring being substituted. The first reactions, benzene react with concentrated nitric acid in concentrated sulfuric acid at 50 to 55 degrees Celsius. This will produce nitrobenzene and water. One of the hydrogen atoms at benzene ring is substituted by nitro groups. Name reaction is nitrations. Now we look at the second reactions. Benzene react with halogens X2, it can be Cl2 or Br2, in the presence of Lewis acid, FeX3 or Fe, which act as a catalyst. If chlorine is used, the catalyst is FeCl3. If bromine is used, the catalyst is FeBr3. The product is halobenzene and hydrogen halides. If chlorine is used, the product is chlorobenzene. If bromine is used, the product is bromobenzene. As you can see here, one of the hydrogen atoms at the benzene ring is replaced by halogens. Name of reaction is halogenation. It can be more specific. If bromine is used, the name reaction is bromination. If chlorine is used, the name reaction is chlorination. The third reactions, benzene react with acid or acyl chlorides in the presence of Lewis acid AlCl3, which is a catalyst to produce aromatic ketone and hydrogen chlorides, where one of the hydrogen atoms at the benzene ring is replaced by acyl groups. Name of reaction is Philip-Claude acylations. The fourth reactions, benzene react with alkyl halides or haloalkanes RX in the presence of Lewis acid LX3. The X can be Cl or Br to produce alkyl benzene and hydrogen halides, where one of the hydrogen atoms at benzene ring is substituted by alkyl groups. Name of reaction is Philip-Claude alkylations. Nitrations, halogenations, Philip-Claude acylation, Philip-Claude alkylations, all of them is electrophilic aromatic substitution reactions. Now we look at the reaction involving the side chain of benzene, where the benzene is not being affected. It only affected the side chains. Name reaction oxidations. The requirements for alkyl benzene to be oxidized, as you can see on the screen here, the carbon that is directly attached to benzene ring is called benzylic carbons, and the hydrogen attached to the benzylic carbon is called benzylic hydrogens. The requirements for alkyl benzene to be oxidized, you must have at least one benzylic hydrogens. We look at the example. Methylbenzene react with strong oxidizing agent, potassium permanganate acidified heat or potassium dichromate acidified heat. It produces benzoic acid and water. On the screen here you can see that only the CH3 will be changed to COH. The benzene ring still remain unchanged. The second example, ethylbenzene react with strong oxidizing agents. It will also produce benzoic acid, carbon dioxide and water. As you can see here, the ethyl groups will be converted to COH. For the first example, we have 3 benzyl hydrogens. For the second example, you have 2 benzyl hydrogens. For the second example here, you have byproduct carbon dioxide. Why? Because for the side chain, you have more than 1 carbon. Now we look at the second reaction involving the side chains. Ethylbenzene react with bromine under sunlight, represented by ultraviolets, to produce 2 products, minor and major product. As you can see here, we have minor and major. For the minor product, the hydrogen is a primary hydrogen, is substituted by bromine. For the major product, the secondary carbons, so we have second hydrogen, is replaced by a bromines. So this is a reaction involving the side chains. Name reaction is halogenation. If bromine is used, is bromination. If chlorine is used, chlorination. Third reaction is free radical substitution reactions. So this reaction of benzene and its derivative.
Thank you for watching.